Hello student, welcome all of you at AriserTalent. So we are on the second chapter of our chemistry class 10, that is acids, base and salt. So until now we have discussed about the classification of acids based on various characteristics, like based on the origin, based on their sources, based on their reaction and based on their several characteristics. Now in today's lecture, we are continuing this lecture with the type of the acids and their chemical formula and the uses we have discussed in our previous lecture. So in our previous lectures, we have discussed about the uses of mineral acids. So in today's lecture, firstly we will discuss about the uses of some of the organic acids. So our today's topic is uses of some organic acids. So we have many type of organic acids, as we have already discussed that organic acids are those acids which we obtain from certain organisms, like it may be the plant, it may be animals, or it may be some other source, but it must be organism. So we have few acids in this category. So here we are writing serial number. Then in our next category we are going to write the name of the acid. Our third category will be type of acid. Then we will deal with its chemical formula. Then the last step will be the uses. So firstly, we will write the name of the acid, its type, its chemical formula, and lastly we will write the use of the acid. So in the category of organic acids, we have our first acid, that is known as acetic acid, which is very common acid. So our first category of acids is, name of acid is acetic acid. And what will be its type? It is a type of organic acid. It will be organic one. Its chemical formula will be CH3COOH, and the acetic acid is basically found in vinegar. It means it is used for cooking purposes, and sometimes it is used as a mixture in case of paints and certain type of emulsions. So what is its use? In vinegar, or it is used as solvents in paints. So this will be the first use of our acid, that is acetic acid. Now we will on our second type of acid. The second type of acid will be formic acid. Formic acid is again in the category of organic acids, and its chemical formula will be HCOOH. This will be the chemical formula for formic acid, and where it is found? It is found in the sting of bees and ants, and it is used for making certain type of chemicals. So its use will be, it is found in sting of ants and bees, and used for preparing chemicals. So this will be the use of our next acid, and this acid is formic acid. So we have dealt with our second acid. Now we are proceeding to our third category of acid. Our third acid will be benzoic acid. So the third acid will be benzoic acid, and it is having a general form, or it is counted in the category of organic acids again. It is having a general formula C6H5COOH. This will be the formula for benzoic acid, and benzoic acid is basically used as a preservative in the food items. So its use will be used as a food preservative. So this will be our third category, that is benzoic acid, which is used as a food preservative. Now our fourth type of acid will be citric acid. So the fourth category of acid will be citric acid. So I am writing fourth acid here, citric acid. Citric acid is again counted in the category of organic acids. It is having a general formula that is equal to C6H8O7. So its general formula will be C6H8 and O7. Now its use I am writing here. Citric acid is basically used in as a it can be obtained from the citrus fruits such as lemon and oranges. So it is found in lemons and oranges and some sort of citrus fruits. So it will be about the C6H8O7. Now we are with our last formula, that is of the organic acid of known as tamarind. So our last formula will be of tamarind, and tamarind is having a general formula C4H6O6. This will be the general formula of tamarind, that is tartaric acid. Tartaric acid is basically found in tamarind, so I can say that it is tartaric acid. The name of the acid will be tartaric acid, and it is basically found in tamarind. So this is the general use of some of the organic acids that we have discussed today. In our previous lecture, we have discussed about the uses of mineral acids. So this will be the category of some of the general organic acids, and this question is important from a very short questions point of view, that is of your 1 mark question. So if you want to copy it, please copy it from here. Now we are proceeding to our next topic. Our next topic will be the chemical properties of the acid. So the next property will be chemical properties. So our next topic will be chemical properties of acids. So students, in chemical properties of acid, basically we are going to deal with the chemical reaction of acid with certain form of compounds. So firstly, we will deal with the reaction of acid with more active metal, then we will compare it with less active metal, then we will see its reaction with metal carbonate, bicarbonate, having a reaction between acid and base, and the fourth category will be reaction of metal oxides with the acid. So our first category will be, firstly we will deal with reaction of metals with acids. So if I'm saying about reaction of metal with acids, I have to consider it in two categories, that is more active metal or the less active metal. The hydrogen element is considered as a standard, and the metal above the hydrogen in the reactivity series will be counted as a more active metal, and the elements below hydrogen will be considered in the category of less active metals. So we will have two categories here: reaction with more active metal and our second category will be reaction with less active metal. So here we have the two categories in case of reaction of metal with acids, but firstly I'm going to say you a simple thing about the reactivity series. The metal in the reactivity series above hydrogen are considered as an active metal, and below hydrogen are considered as a less active metal. So I am saying about the reactivity series. What happens in case of the reactivity series? We have hydrogen as a standard. If I am comparing the metals with hydrogen, the metal above hydrogen, that is up, are considered as active metals, and the metals below hydrogen will be considered as a less active metal. So if we are going down, the metals will be considered as a less active metal. So if I am talking about the active metals, so in the reactivity series, the metals above hydrogen are sodium, potassium, zinc, calcium and magnesium. So these are the 5 metals which are active, that is sodium, zinc, calcium, magnesium and this will be the 5 metals that are in the above hydrogen in the reactivity series, and we will see its reaction. Sometimes we will consider the reaction with iron also. So 5th metal will be iron. Now we are dealing with our first category, that is reaction with active metal. So what happens when the acid react with active metal? So we are with our first topic, that is reaction with active metal. So the general equation for the representation of reaction with active metal will be, when active metal react with acid, it is going to produce salt plus water. So the product will be salt plus water. So this will be the general equation for the representation of the reaction between acid and metal. Active metal is going to react with acid, and what we will obtaining in the product side, we are getting salt and water. Now we will understand this with the help of an example. Suppose I am considering an example of sodium here. Sodium, that is Na. Na is going to react with acid. that is 2HCl, or we may take another acids also like H2SO4. So it will liberate the hydrogen gas in the solution. So what I am getting here, 2NaCl plus H2. It means either water is formed or the hydrogen gas is liberated in the solution. Now we are taking our next example, that is that is zinc. Zinc is more active metal. Now we are doing its reaction with another acid that is known as the sulfuric acid, H2SO4. What I am getting in the product side, ZnSO4 plus H2 gas. So what we can see in this reaction, when the active metals are going to react with acid, we will get salt plus hydrogen gas in the product side that we are observing here. So this is the basic reaction with the active metal. Now we are on our next category. What happens if the metal is non-active? Non-active means it is below hydrogen in case of the reactivity series. So our next topic will be reaction with less active metal. So what happens in this case, when there will be a reaction with a less active metal of the acid, this will show no of the reaction. It means none of the thing is produced in the product side, and we will not get salt plus hydrogen gas. So if I am considering here less active metal and I am reacting it with acid, then in the product side we will get no reaction. It means no product will be formed in the product side. So this will be the general representation for the less reactive metal. So our first category was reaction of acids with metals, that is active metal and less active metal. Now we are proceeding to our next category of the reactions, that is reaction with metal oxides. So before that, you can copy it from here. So our second category will be reaction with metal carbonates. So if any acid is going to react with a metal carbonate, what we will get in the product side, we will get salt plus water with the bubbling out or the evolution of carbon dioxide gas in the process. So the general equation is, if I am considering metal carbonate and what we are doing here, we will react it with acid, any of the acid. What we will get in the product side, we will get salt plus water with the evolution of carbon dioxide gas, so with CO2 gas. So this will be the general equation representation of the reaction between acid and metal carbonates. Now we will understand this with the help of an example here. So I am taking an example. I am taking a metal carbonate, that is, it may be the calcium carbonate or it may be sodium hydrogen carbonate, that is basically known as sodium bicarbonate, is known as a baking soda. So we will take here NaHCO3. It means it is sodium bicarbonate. It is sodium bicarbonate, basically known as baking soda. We will do its reaction with H2SO4. H2SO4 is sulfuric acid. Now, what we will get in the product side? We will get Na2SO4 plus water plus carbon dioxide. It means Na will react with SO4 to give Na2SO4, that is sodium sulfate, and sodium sulfate is basically a salt. So this will be sodium sulfate and sodium sulfate is actually a salt. Now this is water and this is evolution of carbon dioxide gas. So this will be the general representation of a reaction with metal carbonates. So I hope this will be easily understandable by you with the help of an example. Now we are moving to our next category, that is reaction with metal oxides. So our third reaction will be reaction with metal oxides. So if we do any reaction of an acid with metal oxide, what we will get in the product side? Again we will get salt plus water or with the evolution of hydrogen gas. So if I am taking here any metal oxide and I am doing its reaction with any acid, what I will get in the product side? Salt plus H2. So this will be the general equation representation of any metal oxide with acid. Now we will take an example for understanding this. So we will have an example. Suppose I am considering a metal, that is zinc oxide. Zinc oxide is an oxide of zinc, and what we will have? ZNO. Now zinc oxide is going to react with HCl. So what we will get in the product side? We will get ZnCl2 plus H2O. It means zinc will react with chlorine and H will react with O to give H2O, and I am substituting 2 here because for balancing the equation. It means when any of the metal oxide will going to react with any of the acid, what we will get? We will get salt plus water. So this will be the general representation of the reaction of metal oxide with any of the acid. Now we are on the last category of our reactions, that is reaction of acid and base. So our fourth category will be reaction of acid with base. First category we have discussed is reaction of active or non-active metal with acid. Second category we have deal with reaction of metal carbonate with acid. Third category we have discussed is reaction of metal oxide with acid, and we are on our last category, that is reaction of acid with base. Now what happens when acid and base react? Acid react with base to give salt and water. If an acid and base are reacted and what we are getting in the product side is salt and water, this reaction is basically termed as neutralization reaction. So this will be the general representation of the equation, and this reaction is basically known as neutralization reaction. So students, this question is important from your exam point of view, that explain the neutralization reaction with the help of an example. So this will be the general representation of the neutralization reaction, and neutralization reactions are those reactions in which acid react with base to give salt and water. Now we will take an example to understand this reaction. Firstly, I am taking acid, that is HCl, and I am taking one base, that is NaOH. What I will get in the product side? Na will going to react with Cl, NaCl, and OH will form a bonding with hydrogen, and we will get H2O in the product side. So this is acid, this is base, and what we are getting in the product side, we are getting salt and water. So this reaction is actually termed as neutralization reaction. So this will be the general example for neutralization reaction. That is, acid and base react with each other to give salt and water. So in our today's lecture, we have discussed about the chemical property of acids. So this lecture is over for today, and we will deal with our next topic, that are bases, in our next lecture. Thank you so much and have a nice day.